Okay, welcome friends. Today we are going to discuss arithmetic progression as part of your business mathematics syllabus, and this would also be useful for those who are preparing for various competitive exams because you might see some of these questions appearing in the quantitative aptitude portion of those exams. So let us start off. Now let's first understand what do we mean by arithmetic progression. Now let's have a look at this particular series. This series consists of 5 numbers, 2, 5, 8, 11 and 14. Now what is the difference between the first two numbers which appear in this series? 3. 5 minus 2 is equal to 3. Again 8 minus 5, again 3. 11 minus 8, again 3. 14 minus 11, again 3. This basically is an arithmetic progression. A series in which the difference between any two consecutive terms is equal is called an arithmetic progression. So how do you find out whether a particular series is an arithmetic progression or not? You look at the difference between two consecutive terms. So for every such pair, the difference should always be the same, which is the case here in this particular series. 5 minus 2, 3. 11 minus 8, 3. 14 minus 11, 3. Is this okay? Now, this difference is called the common difference. 5 minus 2, as you have seen, is equal to 3. 8 minus 5 is equal to 3. And 11 minus 8 is equal to 3. So this difference is called the common difference. And it is denoted by this letter small d. The first term of a series is generally denoted by a. Though in different books you may find different notations also. But for our purpose here, we would be using a to denote the first term of the series. So in this particular series 2, 5, 8, 11, 14, you would say that a is equal to 2, the first term. Now let us have a look at one example. 1, 11, 21, 31 and 41. There are 5 terms in the series, and if you look at the difference, you would find that the difference is always equal to 10. 11 minus 1 is 10. 21 minus 11 is equal to 10. 31 minus 21 is equal to 10. 41 minus 31 is equal to 10. So basically the difference is same, which is the common difference, and hence we can conclude that this particular series is basically an arithmetic progression. So before starting off or before trying to attempt a particular question, you have to determine whether a particular series is an arithmetic progression or not, because whatever the discussion would follow now, that would only be applicable to arithmetic progression. So what you have to keep in mind is, first of all, ascertain whether the series is an arithmetic progression or not. Now let us take a look at another example, a slightly different example just to make you understand things. Minus 3, minus 7, minus 11, minus 15. There are 4 terms of the series. Whether this is an arithmetic progression or not, what do? Try to find out the difference between the first two numbers. You would find that the difference is minus 4. Minus 7 minus 3 is equal to minus 4. Likewise, the difference between the third and the second number in the series, minus 11, which you can see here, minus 11 minus 7 again is equal to minus 4. Again, if you look at the difference between the last two numbers in the series, that is the fourth term and the third term in this series, minus 15 minus 11 again is equal to minus 4. Please do keep in your mind that we are actually dealing here with negative numbers, and then therein you need to know how to subtract negative numbers. So that is something that you have to keep in mind, otherwise you might go wrong. That is why I have taken up this particular example. So is this clear now? I'm repeating it again so that you can understand it better. The first term is minus 3, the second term is minus 7. The difference is minus 7 minus 3, which ultimately becomes minus 7 plus 3, and it comes out to be minus 4. Again, the difference between the second and the third term, minus 11 minus 7, which you can see here, again minus 4. Likewise is the case for the difference between the fourth and the third term, which again you can see here. So basically, since the difference is same throughout, we can conclude that this is an arithmetic progression. Another example, minus 5, 1, 7, 13, 19. You can do this calculation on your own, that this is basically a arithmetic progression, and the common difference is 6. Okay, now once you have found out whether the series is an arithmetic progression or not, then we can try and find out the nth term of an AP. Now what do we mean by this? The formula that we are going to use is Tn is equal to a plus n minus 1 in brackets into d. Nth term of an AP means that, suppose for example you have been given an AP and you have to find the 13th or the 14th or the 20th or the 25th term. You can find that term just by making use of this particular formula. How? Let us find out. So this is the basic formula that we are going to use. We'll be doing some questions as well. Now this formula Tn stands for the nth term which you want to find out. What is A? You would remember that it is already been discussed, and A is the first term of the arithmetic progression. What is N? Again, N is the number of terms in that particular arithmetic progression. Once we attempt the question, you would be able to get an idea about how to go about solving these questions. Now, what is D? Common difference we have already discussed. D is equal to the common difference. Now let us do an example to actually find the nth term of an AP. So this is the question that you would have to attempt. You have to find out the 7th term in the series 3, 13, 23, 33. So first thing that you have to do is, do you remember what is the first thing that you have to do? Yes, the first thing that you have to do is to find out whether actually this is an arithmetic progression or not. Because mind it, if this is not arithmetic progression, you actually do not have any formula to find out the nth term. So the first thing that you have to do is ascertain whether this is an arithmetic progression or not. This seems like an AP because the difference is 10. How do you find out the difference? We have done it already in the last slide. 13 minus 3 is equal to 10. 23 minus 13 is equal to 10. 33 minus 23 is equal to 10. The difference is same throughout. That is to say that the common difference is 10, and that is why this is an arithmetic progression. Once we are sure that this is an arithmetic progression, we can go forward, use the formula that we have just discussed to find out the 7th term in this series. Here, what is the first term? A. A is equal to 3. Do you recall that the first term we denote using the alphabet A? So A is equal to 3 and N is equal to 7. Do you remember that we had discussed just a little while ago that N is the number of the term that you need to find. 7th or maybe 17th, or in this case it is 7th, it could be 17th, it could be 700th, it could be 10th, it could be 20th. So the number of the term which you want to find out. So N is equal to 7 because we need to find out the 7th term. So basically we have to find out T7. T7 stands for the 7th term. You might find a difference in notations in different books, but the ultimate formula would be the same. So we have seen the formula. T7 should be equal to A plus N minus 1D. We have already discussed this formula. We have already had a look at this formula. Now please have a look again. A, we have already seen that the value has got to be 3. N and D, if you put these values, this is the calculation that you'll have to do. You please keep on doing this calculation in your notebooks as well. So basically the answer would come out to be 63. So the 7th term is going to be 63. Can we cross check it? You cannot always do this, but you can, at least in this case, you can cross check. How? The 7th term in the series 3, 13, 23, 33. The 5th term has got to be 43. The 6th term has got to be 53. And so the 7th term has got to be 63. So you can do you can do this kind of a stuff here. You can do cross check here, but you may not always be able to do that. Suppose if you have been asked to find out the 700 term, so you would not be able to do that. But here you can do the cross checking. So I hope you get this. Okay, now we are moving on to another example. Let's take some more examples. Let's take this example. I have deliberately used negative numbers so that you are able to attempt such questions when they appear in your exams. Find out the 10th term in the series. Now the series has been given -2, -5, -8, -11, -14. Do you believe that this is an arithmetic progression? Yes, this is again an AP. Why? The common difference D is equal to -3. Have a look at it. -5, the second term, we are subtracting the first term from the second term, that is -5 minus -2. comes out to be minus 3. Again, let's do this for the second and the third term. Third term minus second term would be minus 11 minus 8 minus 5, which would again be equal to minus 3. Please keep doing these calculations in your notebook, otherwise you may not be able to remember. Likewise, for the fourth and the third term, you will find that the difference is still minus 3. Likewise, for the fifth and the fourth term, minus 14 minus 11 would again come out to be minus 3. So yes, we can conclude that this indeed is an arithmetic progression, and now we can apply the formula that we have already had a look at. Again, the first term, a is equal to minus 2. You can have a look here. What is n? We have to find the nth term. The 10th term we have to find out. So that is why the value of n is equal to 10. So again, putting these values in the formula, T10, yani we have to find out the 10th term is equal to a plus n minus 1d. We'll be putting in the in this particular formula, we'll be putting in the values. A is equal to minus 2, n is equal to 10, and d is equal to minus 3. And we will get this answer. The answer is minus 29. So the 10th term of this arithmetic progression is going to be minus 29. I hope you have understood. If you have not, you can go back to the earlier part of the video, have a look at the video again, understand it, then only we can move forward, because now we are going to discuss a slightly different thing. Up till now we were trying to find out the nth term. What will be the nth term? Now we are going to find out the sum of the first n terms of an AP. So you understand? Do you understand the difference? Now earlier we were trying to find out the nth term. Let's say the third term or the fourth term. Now what we are going to do now is we are going to find out the sum of first n terms. Let us take an example and you would be able to follow it better. But before that, let us discuss some let us discuss the formula that we are going to use to calculate the sum of first n terms. The formula that we are going to use is S is equal to n by 2 into 2a plus n minus 1d. Mind the brackets. N by 2 you have to do, then it has to be multiplied with the term which is there in the bracket. To do that, you know already the BODMAS rules. So first of all, you have to solve the bracket. So you have to first of all find out the value of n minus 1, multiply it with d, then only add it with 2a, and then whatever the result is, then you multiply it with n by 2. So this is how you are going to move forward. Let us first understand what are the meanings of various terms that we have used in this formula. S is equal to sum of the first n terms of the AP. Keep in your mind that first of all you have to determine that the series is indeed an AP. Once you have determined this, then only you can move forward, because this particular formula is not going to be applicable on those series which basically are not APs. It is going to be applicable only on those series which are arithmetic progressions. The first thing that you have to do is you have to determine whether this is indeed an AP or not. If indeed it is an AP, then you can go ahead, you can use this particular formula. S is equal to the sum of the first n terms of the AP. N is equal to the number of terms which are there. Once we attempt the question, you would be able to understand the meanings better, and you would be able to have a better understanding of the formula. A, as usual, the first term of this AP. D, you know already the common difference. Now let us take example of let us discuss some examples. So basically now you have to find out the sum of the first 7 terms in the series. Mind it, earlier we were trying to find out the 7th term or maybe the 8th term. The same question I am using here also, the one which we had used to find out the 7th term earlier. You can go back to that portion of the video and have a look at it again. But now here we are not going to find out the 7th term. Earlier we found out it was 63, but we are not going to find that out again. We are going to find out the sum. Basically we are going to add up 3, 13, 23, 33 up to 7 terms, and then we have to basically find out the sum. So this is an AP. You have to determine this first. Once you have found that out, you have to find out what is the value of A. You know the first term, A is equal to 3. The difference is equal to 10. 13 minus 3 is 10. 23 minus 13 is 10. 33 minus 23 is 10. So the common difference is 10. And we have to find out the value of first 7 terms, and that is why n will be equal to 7. The formula that we are going to use now here is S is equal to n by 2, again into bracket 2a plus n minus 1 d. What you have to do now is you have to basically put in these values, and you will find out that the sum comes out to be 231. Can you cross check it? You can cross check it in this case because we are only dealing with 7 terms. You probably would not be able to do this if you are dealing with 700 terms or maybe 100 terms. That certainly would not be possible for you to do it manually, but right now we can cross check it. How can we cross check it? The first term is 3, the second term has got to be 13, the third term is 23, 33, then the fourth, fifth and the fourth term is 43. Sorry, fourth term is 33, the fifth term has got to be 43, then it has got to be 53, then it has got to be 63, and we have calculated that it is equal to 231. So basically this formula is all fine. We are not having any issues with the formula. We have cross checked it, but mind it, you would not always be able to cross check it. For example, if I ask you in the same question, if I ask you to find the sum of the first 200 terms, it would not be possible for you to add up all those terms. So then you use the shortcut, you go to this particular formula, use this formula, and you would be able to find out the sum of first 200 terms as well. I suggest that you can attempt this question also. Okay, now we are moving ahead with another example. Find out the sum of all the terms in the series 5, 10, 15, 20, 25, 50. Now this is a slightly different question. Why is this different? Can you guess? Give it a moment. Try to think for a moment. Pause the video. Think for a moment. Why is this different? You don't have to find out the nth term. You have to find out the sum of all the terms. But do you know how many terms would be there? You know that the first term is 5, second term is 10, 13 is, then the third term is 15, then we have got 20, 25. The difference is same throughout. So we know that it is an AP. The difference is 5, same throughout, an AP. You know that. But the point is, there's one thing missing. Now what is that? A, you know, the first term is already there, 5. The common difference is equal to also 5. So that is there. But what about n? So you have to find out the sum of how many terms. We have not been given the total number of terms. We have only been given the last term which is there in the series. So we don't know how many terms. Yani we do not know whether 50 is the 8th term or the 10th term, or probably it could be the 12th term also, but we are not sure. So how are we going to do this? So let us try and do this. What you have to basically do here is, first of all, find out which term is actually 50. Find n using Tn is equal to a plus n minus 1d. Here you know what a is, here you know what d is. Here you also know that 50 is some term, a particular term, but you don't know what is the value of n. Which term is 50? So basically you can use this formula to find out which term is the 10th term or the 12th term or the 15th term. Which term actually is equal to 50? So let us try and find this out. Once you are able to find this out, then try and find out the sum, because now you will get to know what n is equal to. Using the first formula, Tn is equal to a plus n minus 1d. Tn you know 50, a you know 5, d is equal to again 5. So can you find out the value of n? Simple mathematical calculation, you can find out the value of n. Once you have found out the value of n, you don't need to worry anymore, because now you have got all the values. You can calculate s. N by 2, and you already have found out. A and d have been given. You can easily calculate the sum. Can you do this? Kindly attempt this question in your home. In case you come across some problem, you can discuss it with your friends. And once you are through with this question, I would like to know whether you have understood the whole lecture or not. And so let us have a small test to test your understanding. These are the questions that you have got to attempt. In case you are still not very sure about a particular content in this particular presentation, in this particular video lecture, you can always contact me and then we can discuss again. But I suggest that you also discuss it with your friends. Okay, then these are the questions that you have to attempt. You can pause the video here, have a look at the questions, note down the questions, and try and attempt as many questions as possible. So thank you very much for your time. Kindly do these questions. The next video that would follow would be on geometric progressions. Thank you very much.